In this video, you will learn how to solve different math problems to prepare for the ACT exam. At a bottling plant, 10,000 liters of carbonated water are needed to produce 3,000 bottles of soda. How many liters of carbonated water are needed to produce 750 bottles of soda? So we are asked here to find the number of liters of carbonated water needed to produce 750 bottles of soda. Now, to do that, we need to set up a proportion with ratios of liters of carbonated water to bottles of soda. It is stated here in the problem that 10,000 liters of carbonated water are needed to produce 3,000 bottles of soda. So that would be 10,000 liters of carbonated water per 3,000 bottles of soda. Now we can let X be the number of liters of carbonated water. Let me just be the liters, number of liters of carbonated water needed for 750 bottles of soda. So that would be X per 750 bottles. So this is our proportion now with the ratios of liters of carbonated water to bottles of soda. Then we cross multiply, so we can solve for X. This would become 10,000 times 750 equals 3,000 X. Then we divide both sides by 3,000. Therefore, X would just be 10,000 times 750 over 3,000. And this is 7,500,000 divided by 3,000. Therefore, X is equal to 2,500 liters. Should be here. Therefore, 2,500 liters of carbonated water are needed to produce 750 bottles of soda. So the answer here is letter C. Reggie knows how to make 5 different entrees, 4 different side dishes, and 6 different desserts. How many distinct complete meals, each consisting of an entree, a side dish, and a dessert, can Reggie make? Now, we are asked here to find the number of distinct complete meals that Reggie can make from 5 different entrees, 4 different side dishes, and 6 different desserts. So how are we going to do that? We just have to multiply the quantities in the 3 different groups together. So we can just simply multiply 5 times 4 and 6, and this would give us 120. Therefore, there are 120 distinct meals that Reggie can make out of those 5 different entrees, 4 different side dishes, and 6 different desserts. So the answer here is letter J. If b is equal to a plus 3, then a minus b to the 4th is equal to. Now to find a minus b to the fourth here, we're given the value of b, which is equal to a plus 3. Then we just have to substitute a plus 3 for b. So we have a minus b to the fourth. Then we substitute the value of b, which is a plus 3. So this would become a minus a plus 3 to the fourth. And then we simplify the expression inside the parentheses. This would become a minus 3 to the fourth. Then a minus a is just 0. It cancels out, and then we're left with negative 3 to the fourth. Negative 3 to the fourth is negative 3 times negative 3 times negative 3 times negative 3. And that is just equal to 81. So the answer here is letter F. For all pairs of real numbers s and t, where s is equal to 4t minus 7, t is equal to. So we are asked here to solve for t. And we're given this expression s equals 4t minus 7. Now to solve this equation, we just have to add 7 to both sides. Then this would become s plus 7 equals 4t. Then this cancels out. Then we divide both sides by 4. This cancels out. Therefore, t is just equal to s plus 7 over 4. Therefore, the answer here is letter K. The oxygen saturation of a lake is found by dividing the amount of dissolved oxygen the lake water currently has per liter by the dissolved oxygen capacity per liter of the water, and then converting that number into a percent. If the lake currently has 6.4 milligrams of dissolved oxygen per liter of water, and the dissolved oxygen capacity is 9.5 milligrams per liter, what is the oxygen saturation level of the lake to the nearest percent? Now to find the oxygen saturation level here, we divide the current number of milligrams per liter by the capacity milligrams per liter. So we're given here the lake currently has 6.4 milligrams. Okay, 6.4 milligrams of dissolved oxygen per liter of water, and then we divide that by the oxygen capacity per liter. So that is 9.5 per liter. Well, this is oxygen capacity per liter. Then dividing 6.4 by 9.5, this would give us 0.6737. We round it off, so this is approximately. And then it says here to the nearest percent, so we need to convert this to percentage. We just have to multiply this by 100%. So this is just equal to 67.37%, which is approximately equal to 67%. So the answer here is letter B.